So we're going to go over the problems from earlier that I mentioned in the review, and hopefully this will help you out. Now, it doesn't guarantee these will be on there, but just maybe a memory job for you. So we're looking at just a quick scan. What's the price of the cedar needed to make this board? So it's a puzzle board that's a 4x3, and so you got a rectangle, and it's 3x4, and you can read on real quickly. It has a price of $3 per square foot. That's a hint that it is an area problem. And area is, of course, base times height, so that'll be 12. And if it's $3 per square foot, then that'd be 12 times 3, or 36. Easy one right there. All right, so the next one, a little more involved. This is the one on triangles. And quick tip, just thinking about, these are all pretty close to looking at the size of this angle right here at F. They're all pretty close. It could have been obtuse, but we're not sure yet. But they're, you can't just tell by looking at that one. You do see something, hopefully. You've got these matching parts in here. So you got 3 matching angles. And hopefully you'll remember that, hey, there's a big vertical right there. We always start, anytime you got angles, verticals, complementaries, supplementaries, make those come to mind. So those should add up to 132. So it's 3 equal pieces. Split that 132 by 3, and you're going to get 44. Each little corner right there is 44. So, clean it up. Then that one little triangle is going to be 44. And so we've got 44 in that corner. Still trying to find this corner, but remember, there's another thing on the checklist. We don't have right angles for complementary, but we do have supplementary. So right here, supplementary, 132 subtracted from 180, and you get 48 for this angle. Does it say they're parallel? Looks like we're going in that direction. These look like parallel lines, and yes, it does say that. So that 48, remember, correspondings will jump down in the same position. So that would be 48 up in that corner. So 48, 48, 48, and 44 in that triangle should add up to 180. So makes 88 for your answer. But notice all the rest of them are kind of close, so it wouldn't be just one you could guess that easily for it. Okay? Just remembering some basic facts. All right, then we go to this one about the hikers. Now, one thing I noticed right in front, and hey, read that question. What's the height of the tent? You don't need to read most of that other stuff if you're thinking about just the height of the tent. The front of the tent looks like this. It's got 6 across the bottom. The sides have a length of 6. And so it looks like that is equilateral. It is, okay. And so you're splitting that down the middle. The height would hit at a right angle. Remember, that's an altitude, and that's going to split this bottom in half, 3 and 3. And so, hey, that's one of those special right triangles. They love to put those on there. This is the short leg. This is the hypotenuse. Remember, the special 30, 60, 90 gave you an x and a 2x, and this would have been the x square root of 3. So your short leg is 3, and so it'll be 3 square root of 3 would be your height. And that's how they're going to write that answer. I didn't put it on this slide, but that was the right choice down there below. All right, then you get into those problems where it has multiple questions to go with it. Now, don't freak out when it looks like, just something crazy. It is a rectangle, so you're going to have right angles in the corner. The first question is just how long is BC? Well, look right there. That's a right triangle. And maybe you remember about the triples that work out perfectly. 3, 4, 5 was 1. Well, those are multiples of 3, 4, 5. So if you say times 5, times 5, times 5, that's one of those multiples that comes out. That one side's 15, this was 25, so the other one's got to be 20. So there you go. There's that answer. So that side is 20. Then the next part is asking on this same triangle about the expression for sine of CDA. They're not doing trig here because where is it? Angle CDA. That's this whole corner. You could have this on here. Let's see if they're going to do it that way. Sine. So we do have the 39, so we could do that. So it would be sine, of course, is opposite over hypotenuse. If this is our big triangle right here, and we're looking at CDA, this corner right in here, then the hypotenuse, of course, is 39, or AD, okay, AD on the bottom. So it's going to have AD on the bottom, all right? And then your opposite would be CA, or AC, not CD. So answer F. So it's not that impossible. They give you these crazy drawings, but it's really not that bad. Now, this third one on this one, a little more, and they did something like this, saying, wait, go back. It won't go back. I'm sorry. All right. Okay, let's see if I can draw it. It won't go back on me, and then I have to re-record the whole thing. So you had, it was asking for like a line that went from the midpoint here to the midpoint over here. And it might have cut those two in half. And then B was reflected across that. So B would have been down there. And then they were saying point F. You had these lines coming here. And then another one here. And they were saying if you did a new line that came down to this point, and I think it went to F, I can't remember. It's like these are going to this makes a rectangle. So these bisect each other. These match as well as these. So it plays in different factors of what would match. But you have this whole length. So if it's cut in half, then they're going to ask you, like, what's the distance right here? Well, there's your little right triangle, and you could work that out as well. It was the midpoint up here on the top. So it's a little involved on that one, but not so. Okay, so now, excuse my husband and my son, and they're screaming at each other. They're having to make dinner together. They're not happy about it. But so is the winner. And you got to remember things like your formula for finding the center of the circle. So remember, when you put in your formula, the plane, let's say diameter of circle on a standard plane, you don't have to have it exact, has endpoints. The diameter ends at 2.8, so over 2, up 8 maybe, and then back 2, up 6. So it's like this is the diameter doing something like this. All right, so when we draw it, okay, when we draw the circle, in the formula for the circle, you have the center has a certain number that's being subtracted, even if it's negative or positive, doesn't matter, plus the x point and the y point, and they just put h and k in there for them. And then the radius is squared. That's your key right there, the radius squared. So we need to figure out what's the radius. So the distance between these 2 points is what they're working on. They're going from 2.8 to 2.6. Pretty involved problem. See, it's in the 30s. So you're going to say, let me see, 2.8. Okay, I was reading it wrong. So you need the midpoint of those 2 points. Halfway between those 2 points would be the center. So midpoint between them, my class, we always lined them up and then divided it by 2. The x's get added. You get 0 divided by 2, 0. 8 plus 8 plus 6 is 14. Divided by 2 gives you 7. So 0, 7 would be your center. And that would be midpoint between them because that's halfway between. If that's the diameter of the middle, it's going to be halfway between those 2 points. Okay. You could then take it and figure out your radius and all that, but you don't need to on that one. The one below it is and what's the circumference if I give you the radius? Well, there's 4. Okay. Circumference is pi times diameter. So if you got a radius of 6, the diameter is going to be 12. 12 pi, and I can't remember if they put it in terms of pi or if they worked it all out. So 12 pi or pi times 12 if you did it in the calculator. Okay. Now I always put one of these crazy ones on here. Sort of, it's a ratio problem, comparing the areas, what fraction area is shaded in here. So the area FGH, make sure that's what they're talking about. That shaded part is what fraction of the area. So the shaded over the whole area. Or think about how this would have been divided up. If I divided it like this, or forget about the shaded part right now, that would have been 1, 2, 3, 4 major parts, right? So 1/4 is 1/4 shaded all in. No, so it's definitely not that. Well, what if I split it? The way they split it right there, you can say, that way, that way, that way. That gives you 1, 2, 3, 4, 5, 6, 7, 8. Is that whole triangle, part right there shaded in? No, it's not 1/8. So they split that, but they didn't split both like that. They split it like that. Look at the empty ones here. All right. Each, or the regular fourth, 1, 2, 3, 4, 5, 6, 7, 8. That's going to give you 16. Is one of those 16ths filled in? Yes. So there's your answer. So not impossible. Just have to play with the numbers a little bit and see. All right. The volume of the second cylinder is how many times the volume of the first cylinder? Okay, so what they did is they increased the volume on this. And you've got your formula given to you. They didn't expect you to do that. But think about that formula. Pi times radius squared times the height. The first one, they don't even tell you what it is. They just say the second one, this is the volume of the first one, but the volume of the second one, they doubled the radius, 2r. So pi times 2, whatever the radius was, it would be 2 times bigger. So it's not just when you think of 2r, that's got to be squared like that. And then the height was 3 times the size of the height. So we just want to know how much it changed by. So what happens when you square the 2? You get a 4, and then you got 3 multiplied times it. So it's actually going to be a difference 12 times bigger. 4 and 3 get multiplied. So it's 12 times bigger than the original. It's just how much did they change it? So that's the trick there, seeing what it got changed by. Whatever the volume would have been, you multiply it by 12, and that'll be the new one on there. Okay. These always freaked me out back in the day, but now they're no problem. All right. The midpoint of AD to the midpoint of CD. What's the distance of those two parts together? All right. So you can't really grab the midpoint that fast, but A to D, look at it. It's going perfectly diagonal right there. And it counts as 1, 2, 3, 4, diagonally perfect straight right in the middle. So that's got to be the midpoint. And even if it wasn't, we could get it pretty close. The answers they have on there were real far apart from what crazy stuff. And so then the midpoint for CD, that's right here. Watch how it goes. It's going across 1, 2, 3, 4, 5, 6. So wouldn't 3 be the midway? And look, that's right on the dot. So they're wanting you to distance between these two dots. Not just here. Isn't that bad of a problem when you think, okay, I just want to know that. And if you took my class, you know, you had this made. You didn't have to do distance formulas. So rise 1, 2, 3, and run 1, 2, 3, 4, 5. So that's 3, that's 5, and your hypotenuse would be whatever you get from there. So 3 squared plus 5 squared, and your hypotenuse would be that. And so that'd be 9, 25, 34, square root of 34. And I think that was one of the answers on there if they didn't factor. It doesn't factor, so that's good. All right, so not impossible, just a little bit tricky how they did it. Here's one about a vector. Now I used to teach a little thing on vectors, but hadn't had time with COVID and all this stuff going on and classes being shorter. So you don't even have to think about it, because what they're doing is they're rotating it counterclockwise 90 degrees. That means it's going to be going backwards counterclockwise and somewhere out here. Well, what we did remember is when you're doing a rotation, you can go look them up and see, but if you do a 90 degree counterclockwise, the X and Y coordinates switch spots. And if you can't remember which one changes signs, look where it is. The X should be negative, correct? And then the Y is going up, so it's -3, 2. That's an easy one. Just rotate it around. All right, so right triangle, ABC, sine of A. All right, let's see. Sine of angle A, so one of these regular angles is A, is 2 to 3. So that means 2 here, 3 here. And then what's cosine of A? So we don't have a, an adjacent side, but we could find it with a little Pythagorean theorem real quickly. But you don't need to. There's a little shortcut to it. Now, hopefully you know 1, 2, and 3 would not do for Pythagorean theorem. No way. 1 squared is 1 plus 2, 4. That don't make 9. Okay. So forget about the 1 over 3. We know our hypotenuse for cosine adjacent over hypotenuse. The 3 is going to be the bottom. So, and it's not that one because it doesn't have 3 on the bottom. So, and it can't be 1. We just said it was because it wouldn't be enough. How could it be a negative length? No. Okay. So we're down to 2 choices. And square root of 5, we kind of know where that is. Square root of 13. Think about it. Square root of 3. 3 squared is 9. 4 squared is 16. 13 somewhere in between there. So maybe about 3.5 just as a guess. Could this side be a 3.5? No, it would be bigger than the hypotenuse. So it can't be the 13. So you only got one thing left. Okay? So you have your choice there. So look, that was like number 50. And that would have been a hard one for people to figure out. But I don't see why. So just practice. Practice, practice.